Welcome to another tutorial by Longhorn Physics. Today we want to talk about the concept of power. So here's a practice problem. We have a superhero that does 668,183 joules of work pulling a fire truck. Let's go ahead and kind of sketch what's going on here. That's supposed to be a fire truck. And he's pulling it a distance of 5 meters. And he does all this in just 8 seconds. That's seconds there. So here's our superhero. Let's give him a cape here to make him a superhero. And uh, the amount of work he does is 668,183 joules. Alright, so in all our tutorials, like to go over the concept of power and the equation, and then go back and give you a method of solving it to make the arithmetic and algebra much easier. So our equation for power is work divided by time. So in other words, work is also equal to the power times the time you do the work in. So let's spend a few minutes here and go over the terminology and the equation and the corresponding units. So let's go over the equation for power and terminology. Feel free to stop the video at any time and take some notes. So we have power is the work divided by the time. But in order to solve a physics problem, you need to make sure that you know the symbols and the units. So we have capital P for power, and the units in parentheses here are what we call watts. And then work is, the units for work is joules, and the symbol for time is T, and the units are seconds. See the terminology there, see the definitions of power, work, and time. The next step in solving the problem is organizing our data. I like to use what's called the circle label method, where scan through a problem, and wherever you see units or values that look important, you circle them and try and label them with the corresponding units. So here we go. Superhero does this amount of work. I see joules. I know that matches with W, which is the work. And then I scan through here and see a distance of 5 meters. So I know meters goes with distance. And then we have 8 seconds. There you go, is time. And then how much power is generated. That's the capital P. So it looks like we might have some extra data here in our problem that we're not even going to need. All right, now that our data has been collected and organized, of course you could use simple algebra to do this, but I like to use what's called a math triangle. A math triangle makes it much easier to see the arithmetic and takes away a lot of the algebra. It seems like your brain's able to see the math triangles better than going backwards and forwards with all this algebra stuff. So here's how the magic triangle works briefly. Anytime you have an equation that fits the form A equals BC, and we see work is equal to power times time, you simply substitute the letters in the equation in the form ABC. So here's our triangle ABC. The A always goes on top, and B and C always go on the bottom, and the order doesn't matter which way you put these letters. So now I'm going to substitute my A, which is work, P, which is power, and T for C in the corresponding spot. So you have to make sure you put those letters exactly where they need to go there. So next step is to come over here and start substituting the values for your variables. So I know my work is 668,183 joules. I know the time is 8. So now it's a matter of figuring out the power. Now to use the magic triangle, all you need to do is, if you're looking for one of the corner variables, you simply divide the top by the bottom. So since I'm looking for P, all I have to do is divide the top part of the triangle by the bottom corner. And so that ends up being 83,522.9 uh, watts. So power is always the units of watts.